Hey guys, Stephanie Gruen here. Welcome to Ventilation Nation and Integra podcast. We have a special guest here today. This is Mr. Phil Emory. Phil is with Neudorfer Engineers. He's been in the industry for 40 plus years. And today we're going to be talking about building enclosure testing, I think, which we'll lovingly refer to BET, which is not Black Entertainment Television, which I thought maybe my first few weeks that was what it meant when people kept saying BET. So we're going to talk about building enclosure testing, and Phil's a bit of a renowned expert in this field, and I'm really excited to spend the next 15 minutes with you, Phil.
Cool.
So anyway, let's start off with what is building enclosure testing?
Building enclosure testing is nothing more than testing the enclosure. What you're doing is testing the integrity of an air barrier system within the building or a portion of the building, pressurizing and depressurizing, and seeing what the exfiltration and infiltration that you can generate with blower door fans at different pressures.
Okay, so building enclosure testing is testing the pressure in the building?
Yes, you're generating a pressure inside or depressurizing the building or rooms inside of a building to see how much you're pulling through walls, floors, and ceilings.
Mm-hmm. So what does it look like when it fails, if you do enclosure testing and it fails?
It doesn't look like anything other than you just notice that you've got a lot of leakage. You can feel the air moving significantly, but you know your target values when you're testing at what pressure you want to see a certain amount of leakage. If you're exceeding that, you know the building's failing right away.
Okay. So can you tell us a little bit about the history of BET?
Absolutely. In about 2005, the U.S. government was really focusing on energy savings. And so they made an edict for their federal buildings to reduce the energy by 30%. Architects and building science people went to work with facades and walls, insulations, and thicknesses and things like that. They could only get so far, and they weren't getting to that level. The Corps of Engineers in about 2009 looked at what they were doing in Canada and in Europe, and they said, hey, why don't we fix the holes that we have in the building? So they latched on with some building science people and formed a committee to look at taking some of the ASTMs that were out there, and methods,
standards,
American Society of Testing Methods.
Okay.
There was a couple of them out there that discuss how to do this test. They just didn't know if it would work on big buildings, and so they decided to go after the leakage. So in doing so, you need to create an air barrier system, which includes that enclosure. That's where the word enclosure or envelope comes from. It's an air barrier system that encapsulates whatever it is you're trying to encapsulate.
Okay. So if I'm a building owner,
yeah,
and would I know that I need building enclosure testing, or how would I know, or who would approach me or tell me I need this and why do I need it?
It's such a new test here in the United States that of course, the Corps of Engineers and the federal government buildings, they require it. Mm-hmm. But other than that, it's leaking out into the core to code issues. Here in Washington State, we were one of the leading states which made this a code issue to which you had to have this test done. And so that's how it is. It's part of the law.
It's part of the law, but not everybody
enforces it.
Yeah. So a lot of people just bypass it because they know they can go through that little loophole and it won't be enforced.
Yeah, the inspector that shows up that gives them their certificate of occupancy doesn't require it to be done.
So how do we increase enforcement?
What's going on right now is you're failing. When the building fails, they're not supposed to get their certificate of occupancy. And so you're punishing people for the failing. I've always thought that you should be rewarding people by giving them energy credits or whatever if the building's passed. That would generate more of an enthusiasm to do the test, more of an enthusiasm to let's do this right, let's get it done, because we earned something, rather than just someone coming in and says, your building failed, now what do you do? Well, if the air barrier is buried, how do you get to it to fix it? A lot of people just says, well, we can't, it's not practical, let's just move on, give them their certificate of occupancy, move on. That would be a huge issue in my thoughts. the architects and engineers have really got to get on board. It just isn't me showing up and running a test and saying your building passes or fails. You're testing the integrity of an air barrier system that starts at the design phase. Mm-hmm. It's got to be correctly specified. It's got to be understood. It's got to be buildable. They've got to be able to build it and create the enclosure that they're searching for. It works if they do it right.
So if we're going to educate the market, we should start with the architects at the design phase?
Absolutely. Getting architects, if it's a code issue, and the code is starting to branch off into other states, in Oregon is just now picking it up. I know Title 24 in California is pushing it. New York City, it's been in the residential codes for many states, but just not in the commercial, into larger buildings.
I was going to ask if some states were more enforced than other states.
Yes.
I mean, typically California's got a pretty high enforcement when it comes to these types of regulations.
Yeah.
You said New York?
New York a little bit. Yeah, they're more on the residential side.
Mm-hmm. Yeah, it's weird that this service hasn't taken off. I think it's weird that it hasn't taken off because with energy efficiency being such a high priority on how do we become more efficient, and I don't understand why it's been so difficult to take off.
Yeah, a lot of it
is it you? Are you the reason?
Yeah.
Are you the barrier?
Yeah, the resistance. a lot of it
Phil is very resistant, people.
Yeah. Back in the 70s, we went through what was called the sick building syndromes, where a lot of people were getting sick inside the office spaces. And that was because of people smoking, disease. And the cause of it was because we were trying to save energy by recirculating so much air rather than bringing an outside air or the fresh air into the building. And so a lot of people said, well, if you build this building so tight, aren't we going to go back to that sick syndrome type thing again? And the answer is absolutely not. What you're doing is getting the mechanical system to do what it's designed to do. Push the air through the mechanical system. So it's the air changes per hour that you're going to get. So you're taking the bad air, getting rid of it, and bringing in outside air in. That's the driving force. There's a difference between how much outside air you bring in and how much exhaust air you take out, because the rest of it is going through exfiltration, infiltration of the building. If I can get rid of that exfiltration and infiltration, I bring the outside air and the exhaust air to the same level. So the mechanical system's working very efficiently. Plus, sometimes a building might go a little negative. If you've got mold or mildew in your walls, you're pulling that mold and mildew air right into your building space because the building's negative.
Oh God, there's a lot to think about. So when you're in your car and you hit the recycle button with the recycled air, is that good or bad? I mean, now I'm worried. Should I worry about that?
Not so much, but we don't smoke. But if you're in a hospital or an intensive care or a lab or a compound pharmacy or some of those other places, absolutely it's critical. If you're not filtering that air before it gets recirculated back into the system.
So is there any tie-in to envelope or enclosure testing and commissioning?
Oh, absolutely. And test and balancing and clean rooms.
Mm-hmm. So it's all part of the Ventilation Nation.
Yeah.
That means we chose the right name for this podcast.
Yeah. I could. Mm-hmm. Anyway.
All right. Question for you.
Sure.
What is the craziest project you've ever worked on?
One just popped in my mind when we were talking about, but the one we were thinking about that we talked a little bit about yesterday was a cold storage facility. They're monolithic, huge buildings, mm-hmm. And they're incredibly tight, mm-hmm. and to the point where I was thinking I was going to be bringing in 20 some odd fans. Did the calculation, and it turns out that I just needed one fan. And it was amazing how well the machines worked, the gauges and everything. It was phenomenal testing a building that large and watching how long it took to pressurize and then depressurize.
How long did it take?
Usually about 15 to 20 minutes to get to a pressure. But it was when I disconnected everything and was going to come back and do my last baseline pressure. Usually I can do that in a normal building within about 60 seconds after testing the building. This one took another 15, 20, and it was just, you could just see the air just breathing out through that doorway. It was just constantly coming out there. It was pretty cool.
Mm-hmm. That's interesting.
Kind of nerdy for an engineer.
Engineers, left brain,
yeah.
Stephanie Gruen, right brain, but it works.
Yeah.
So it's interesting because I've been here for a handful of months. Before, 6 months ago, I didn't know much about tab or commissioning or envelope or enclosure testing. So it just seems like I just feel like we're really missing something here in this industry, and that we should be doing more in this building enclosure testing space.
Absolutely, and that's when I was. I just finished, serving as the immediate past president of NEB, and so prior to that, I was the president of NEB, and working my way up.
NEB is an accrediting body.
Yeah.
Just for anybody that's not familiar.
Right, it's the National Environmental Balancing Bureau. Mm-hmm. It's one of our entities that we belong to. Mm-hmm. That was one of my driving speeches that I would give to within NEB, is that we have all these different disciplines and they interrelate. And we need to do a better job. It's the squeaky wheel theory is if you hear one voice, it's usually not going to help too much. But if I can get ASHRAE, if I can get engineers, if I can get commissioning people, test and balancing, everybody going to these architects or the industry or wherever and saying, this is how it all ties in. Mm-hmm. This is what we need, and I need him as much as you need me. Mm-hmm. Our industry would I think greatly benefit for that.
So it sounds like something we need to spend a little more time and do a little more in that space.
Yeah.
So I hear you're retiring at the end of the year. Is this true?
I am.
But maybe next year we'll have a little bit of Phil. We'll see. We're working on it. We've been arguing about this for a few weeks. Okay, so important tips and tricks for new technicians. Can you give me a couple?
Yeah. And it's just not BET, but all of our disciplines within Neudorf Engineers or any other firm within Integra. The sky's the limit. If you really want to make this a career rather than just a job where you're showing up, punching a ticket, there is so much to learn, and the mentoring out that you can get out there is phenomenal. But you've got to want it, and you want to soak it in, and you've got to learn. But the engineering it's fun. It's watching, buildings operate a certain way and being able to troubleshoot and figure out what's going on and why is it doing this or why is it doing that. It really makes for good, after work beer conversation type things. It's fun.
So from a career perspective, you said this earlier, and I'm going to say it, and then you can tell me if I'm wrong. But a young guy comes in out of school, wants to create a career or make a career for himself. A company like Integra Testing Services with locations all over the country, you can enter this space in the building enclosure testing space and really make a name and a career for yourself if it's something that you really want to do.
Absolutely, it's such a new career that it's dying for people to bring in new ideas, and watching the young kids get involved with it on the committee that I served with for NEB it's phenomenal. Mm-hmm. The technology is constantly changing. We're getting new equipment. It's keeping up with it. Is the young kids just love it. Mm-hmm. It's
awesome.
Cool.
Awesome. Well, hey, this was an awesome podcast. Thank you so much for being part of this, Phil. Again, I've only been here a few months. I'm with Integra Testing Services, and building enclosure testing is one of the services that we do provide, and we feel like it's got a lot more that this service could do for the industry and just for the world. So thanks again for joining us, and thanks for listening in. Peace out.
Thank you.